Hello. In today's unit we will continue studying the real numbers, and we are going to see a summary session of what we have seen of the different numerical sets. The objective is, as I said, to remember the relational structure of the different types of real numbers. The set of real numbers has been built up little by little, starting from the natural numbers. And in fact, what we have been doing is extending. We have been adding more numbers. What is the relationship between the different sets? The set of naturals, the set of integers, the set of rationals. That has to be clear in our mind. The requirements are simply the previous units up to real numbers. So we are going to present graphically the classification of the real numbers. In principle, we have a very large set of real numbers. Here, as you saw, we are going to use a terminology in the form of Venn diagrams to represent the sets, and here we have the set of real numbers. All the elements of the set would be in there, in that shaded area, as little dots. The set of real numbers, as we have seen, is actually made up of two. The rational numbers, which are the fractions, and on the other hand, the irrationals. The irrationals are all the real numbers that are not rational. It is a concept that is usually called complementarity. They are complementary. Q and Y. Either it is Q or it is Y. Either it is Y or it is Q. It's a pretty clear separation. We focus on Q. Once we forget about the irrationals, we focus on the set of the rationals. And let's not forget that we had built it from the set of the integers. The set of integers is a set that lives inside of Q. That is, any integer is a fractional number. We simply have to put a 1 in the denominator. Any integer divided by 1 is a fractional number, but it is effectively worth the corresponding integer. Thus, integers live inside the rationals. However, there are rationals, as we know, that are not integers. For example, 3/2, which gives 1.5. The 1.5 is a rational that is not an integer. And we conceive the integers as an extension. As an extension of what? Of the natural numbers. What did we add to the natural numbers to get the integers? Well, remember, the negative numbers. We had the natural numbers and the negative numbers. As it happened in R, here the division is again complementary. Z is divided between naturals and negatives with a small inaccuracy, and that is that 0 lives halfway between the two. 0 is a natural number, as we have said by convention from the beginning, and it is also a negative number because 0 and minus 0 is 0. It is the same value. That's why 0 lives between the two sets. Let's say it would be a point at the intersection of the two sets. Well, this is the relational structure of the different numerical sets that we have seen. Let's try to see an example with several examples to place the numbers where they belong. Here below, we can see a series of numbers. The number e, minus 3/4, minus 2, 5, 3/4, and root of 2. And what we are going to do is to place them in the part of the diagram where they belong. First, we are going to start with the simplest, the number 5. We know that the number 5 is a natural number, and therefore it would go in the purple area. We place it there, and it remains within that area. Does that mean that 5 is a natural number and that's it? No, it means that it is a natural number and everything that contains it. It is a natural number, it is an integer, it is a rational number, and it is a real number. Everything that contains it. It is not an irrational number because it is not within the irrationals, and it is not a negative number because it is not within the negatives. Let's see what happens with the minus 2. The minus 2 would be a negative number. It would go in this lighter area here, which is the area of the negative numbers. It's not a natural number, it's a negative number, but it is within the integers. It is also within the rationals, and it is also within the real numbers. So in particular, it is a real number, a rational number, an integer, and not a natural number. And so we can see with the other examples, for example, 3/4. 3/4 is not an integer, it's a strictly rational number. It's a number that can't fall into the violet zone, and it's a fraction, so it's not an irrational either. Then we have an example of a number that is a rational, and therefore also a real. Minus 3/4 of the same. In this case, it is affected by a sign, But as we know, fractions are composed of integers, not natural numbers, and therefore they can also have their sign. Then both 3/4 and -3/4 are fractional numbers that are not integers. And finally we have these two numbers left, number e and the root of 2. The root of 2 we know is not a rational, as we saw, and the number e is also a famous number that is not rational. They are both real numbers, but they are not rational. That's why both e and the root of 2 end up in this area here. Well, so far, what have we seen? Well, we have seen the relationships of the numerical sets that we had introduced so far, and we have tried to clarify when we have different numbers, how are they called? Because for being a natural number, it doesn't have to stop being a real number. That's all, thank you.